Ever wondered why massive ships don't sink in even the most furious storms? This question may have sparked your curiosity at some point. It's not just a simple query, but a matter of life and death for those who brave the high seas. Imagine colossal ships, weighing thousands of tons, yet they float effortlessly on water, undeterred by the waves and wind. How is this possible? The answer lies in a simple but profound scientific principle: buoyancy. At its core, buoyancy is all about the interplay between gravity and the upward force exerted by a fluid, in this case, water. This principle is the invisible guardian that keeps these floating giants from succumbing to the ocean's depths. But don't be fooled. It's not just a case of float or sink. There's a sophisticated science behind it, a delicate balance that ensures the survival of these maritime marvels in the face of nature's wrath. So, let's dive into the science that keeps these steel behemoths afloat. You might have heard of the term buoyancy, but what does it really mean? Well, buoyancy is like a superhero power that allows objects to float or rise in a fluid. It's the force that opposes gravity, keeping things afloat instead of sinking. Imagine you're in a swimming pool with a beach ball. When you push the beach ball under the water and let go, it pops right back up. That's buoyancy in action. Now let's talk ships. A ship, despite being a massive structure made of steel, doesn't sink because it displaces a large volume of water, which creates a buoyant force. This force is equal to the weight of the water displaced by the ship. If the weight of the water displaced is greater than the weight of the ship, voila, the ship floats. But it's not just about weight and water displacement. The shape and design of a ship play a crucial role too. Ships are designed with a wide base and a hollow structure, which increases the volume of water they can displace, hence increasing their buoyancy. The materials used in construction are also chosen to be lightweight yet strong, further tipping the balance in favor of buoyancy. So, buoyancy is our first line of defense against sinking. But what happens when a storm hits? Imagine a ship caught in a storm. Waves are crashing, winds are howling. Why doesn't it sink? It's not just a matter of buoyancy. The ship's design plays a crucial role in maintaining its stability in stormy conditions. Let's take a closer look at the hull and the keel, two key elements in this design. The hull, the ship's body, is designed to displace a large amount of water, which increases the buoyant force that keeps the ship afloat. The keel, a beam running along the ship's bottom, adds weight to the lowest part of the ship. This lowers the ship's center of gravity, promoting stability and helping the vessel right itself after being tilted by a wave. But there's more to it. How does a ship counteract the effects of waves and wind? That's where the ship's ballast system comes in. This system allows the ship to adjust its weight distribution by taking in or releasing seawater. When a ship encounters a storm, it can take on additional water to increase its stability. On the other hand, in calm waters, it can release this water to lighten the ship and increase fuel efficiency. So, even in the face of nature's fury, science and engineering keep our ships safe and sound.